Just going live on YouTube. All right, good evening, everyone. I mean, it's evening over here. Hello, everyone, and welcome to the World Innovation webinar. With me, I have the CEO of ECOR, if I'm correct, if I pronounced it perfectly. Yes, Jim Nasr. Thank you so much for accepting our invitation. You may have the floor now.
Excellent. Thank you, Esther. I appreciate your time and I appreciate everybody hopping on this call in these strange times. So hopefully today's conversation will be relevant and interesting to you all. Really is about real experiences and lessons learned that we have had, myself and my team and our extended partners, around using blockchain, particularly in a real-time manner, to support some activities around COVID-19. So I'm just going to get into it, and I would assume at the end of the presentation, we'll have some time for questions. All right, well, let's get going. So just a brief overview of what we're going to cover today, just so there is a baseline. Basically, really, what is a problem, at least in context of COVID-19, and then why blockchain? Why would blockchain even make sense in this context? Then really a segue onto some relevant concepts for blockchain. Not everything by any means. This is not a blockchain 101 session at all. However, I think it's important to do some just baselining on what we're trying to cover. And then really specifically getting into two use cases that we have been, myself, my team have been involved with over the last several months. One is a coronavirus tracking application that is public and has been well cited over the last several months. And then another one is really a specific COVID-19 app for diagnostics and triage that we have been working on with our partners over the last couple of months, which will be live in various outfits and app stores very soon. And then just some closing thoughts. So with that being said, really, what is the problem? So, and I'm not trying to boil the ocean here. I think there's more to this than what I'm going to cite. However, I think there's definitely some things. I'm going to just point to some articles from recent times. So again, this idea of, can we trust the information that is out there, and how do we trust it? You know, who do we trust? Do we trust it just because somebody told us that we should trust it, or they're an authority of some kind? But then there's contradictions there, such as many reports, including many rhetoric reports that we had earlier on with our coronavirus tracker from China and Hong Kong, that information was just erroneous, that the information that we had was way underestimated. And again, there's been a fair amount of articles and newsprint on essentially censorship information, particularly from China. They're not necessarily just China. Again, you know, this really impacts people. Misinformation and distrust impacts communities, particularly communities who are really suffering from this. Communities, minorities in particular here in the US, where we have clearly seen the rate of the impact of COVID has been higher than other communities. And really, how do they establish trust with that information? You know, again, this idea that people are dying, but not necessarily just from COVID, but because we're not fast enough in getting clinical research done. And then also a topic that's very near and dear to my heart is this idea of real-time data. We are in a world of really consumerism, where everybody's used to using their smartphones to get the data from various tools in real time. However, in healthcare, that is really not the case. And I think, as this last article points out, it's real-time data is essential, not just for COVID, but other really important public health causes, such as the opioid crisis, which again is a very big crisis in of itself that has been a little bit subsided, at least in the news recently, because of COVID. So there's more than this in terms of problems, but I think these ideas here cite some of the key things that at least I think blockchain can address. So again, we talked about mistrust, but there's also a lot of manipulation of data, manipulation of information, leading to fake news. And again, sometimes that fake data is there to serve a purpose. It serves a political purpose. It may serve a profiteering purpose. And how do we know what's real versus what's not real? How do we know the provenance of that information? How do we know who the primary data collector was, and whether or not along the way that data has changed? Those are really important things. And right now, it's very, very difficult to discern real versus fake. Okay, so obviously in this session, we're talking about healthcare in general, and obviously we've seen that the very large impact of COVID in public health. My background was formerly at the CDC, the Centers for Disease Control, and having really seen this for myself, very much being involved in building technologies and trying to improve technologies to improve innovation and really improve data flow at the agency. But ultimately, this is bigger than just public health, bigger than one or two agencies. And I think what you're seeing here is what is known as Moore's law, which is this red line here, versus EROM's law, which is this blue line. And what it really shows, is that essentially with Moore's law, which is a fairly well-known idea, you have technology getting faster and cheaper roughly every 2 years, every 18 months. That essentially allows for economies of scale and innovation and return on investments over a course of time. However, with the blue line, what we're seeing is the literal reverse spelling of Moore, called EROM. And this is not my theory. This is there is a Wikipedia page about this, but really the fact that the costs of R&D in pharma life sciences has got more and more expensive, and the productivity has got less and less over a course of many decades. As you can see, this is from the 50s all the way down to these days. And then really our idea, or my idea, is that there's an opportunity for us to tap into some newer technologies, mobile, we talked about smartphones a little bit earlier, Internet of Technologies, wearables, distributed ledger technologies, machine learning, and so on, to really try and reverse this path. Because given the amount of money we spend, at least here in the US, where it's over 18% of the gross domestic product on healthcare, we should do a lot better than this, So yeah, as this cartoon says, but why? Okay, so moving on. So why blockchain and distributed ledger technology? Really, I think the very first thing that we have to think about when we're thinking about blockchain is there a need for us to establish trust? And then that could be because we don't really trust the other parties that are involved in a transaction, or it could be because we don't even know them, right? So therefore we have no real baseline for trust. It's different if you're doing a transaction, for instance, buying and selling, I don't know, Pokemon cards amongst a group of friends where you've all been hanging out for years, right? That's a different scenario. You don't necessarily need to have an arbitrator to create trust for you because you know each other. But in many cases, for larger cases in particular, that's not the case. You don't actually know these people and you don't trust them. But the thing that's important to me though is this, differentiating between trust, because trust can be established with an intermediary. Like for instance, for banking, you could trust SWIFT as a third-party clearinghouse for getting your credit card transactions processed, or other banks for that matter, and they take a fee and they can arbitrate that transaction as it makes sense to them based on their policies or however they make money. There's a difference between that and computational trust, where you're really trusting essentially software and cryptography. Software and cryptography that can be interrogated, that is largely open source, that you can go and look for yourself. So I'm a big believer that when we're talking about distributed ledger technologies, really, I'm looking at, is there an ability to get to computational trust, where it's not a group of 5 nodes and there's a leader node, and that leader node essentially has veto rights and ability to possibly reorder transactions and things like this. So, and then that really naturally leads into whether you want to be thinking about a public distributed ledger technology or public blockchain protocol versus an enterprise one, which is much more limited and private. And I have some thoughts about that. So, so we start with computational trust. Is there anything else? Yeah, unfortunately, there's quite a bit more to consider, right? Trust is just a starting point. But in order for you to use blockchain, you really have to think through a number of other things. I just alluded to public versus private. As you may have gathered, I am a fan of the public model. I believe in many cases, not every case, but in many cases, particularly when you need transaction finality that can be interrogated publicly, right? That is the right solution. I think many healthcare cases, especially the ones I'm going to talk about here, that's the direction that we have gone, and we believe it's a good direction. It makes sense. Anyway, beyond public and private, there's many other things to consider. The number of nodes in the network, the more nodes you have, the more permissionless, the more security you have, just mathematically speaking. But then with that comes additional considerations, costs, governance, etc. You really need to understand tokens and token economy. Essentially, that is the core underpinning, one of the core underpinnings of a public distributed ledger, not necessarily for a private ledger, but certainly for a public one. And it really kind of ties into this idea of basically attributing value to who creates value and using those tokens to essentially reward them. Bitcoin is a good example of that, how you get mining rewards for basically solving that mathematical challenge. Anyways, there are many protocols and many of them are still very much in flux and evolving.
I found this on the web, but basically.
Oh, geez, my Siri is speaking to me. So we need to understand protocols, and then consensus algorithms are also very, very important, depending on what you want to do and how fast you want to do it, and the cost that is involved. You're going to have to make some choices, and there are some trade-offs for that. For instance, Bitcoin uses what's called proof of work. It is designed to be inefficient. It is designed to take some time to get to finality of transactions. However, especially now that the Bitcoin network has so many nodes on it, it is very, very secure. There are other protocols as well, though, and other consensus algorithms that provide the security, but in a different way, and not necessarily with this idea of a basically chained set of blocks, right? So Bitcoin uses is basically a traditional blockchain protocol, where you have one block chained to another, and so therefore changing a transaction way down the line is extremely prohibitive, is very difficult to do and cost prohibitive. Not every consensus algorithm is like that. Other topics that we're not really going to get into too much, just because it's a little bit off course for now, is scaling. We hear this a lot. Using smart contracts, managing keys, which is a very difficult thing right now, and largely an issue for all protocols in terms of really adoption of blockchain. Ideas such as what is on-chain versus what is off-chain, that's a very, very important concept for healthcare in particular, because there are all kinds of laws and rules that you have to follow and policies in terms of data privacy and data preservation, and personal identification, or personally identifiable information, rather, that you must be aware of. So what you are going to put on the chain and what you want to really have to be considered through that lens. And many times what you hear is this idea of a reference on the chain, an encrypted reference or hashed reference, and then that would refer to an off-the-chain set of records that actually has the information, the healthcare information. And then things like partial ownership and all kinds of other things that I think are part of this. So all to say that there's a long tail to understanding how and where blockchains fit, but ultimately everything starts with, do you need to establish trust, and ideally computational trust. Okay, moving on. As I mentioned, I am a big fan of the public DLT. I think it makes sense. It is extremely secure. Again, Bitcoin is a very good example of this, and there are plenty of much brighter folks in cryptography who have proven this, right? And in fact, like I mentioned, the more permissionless nodes you have, the more active your network is, the more likely that you are generating security, particularly through smart use of token economy. But all to say, I believe that a public DLT has really three pillars, or the DNA has three components. There's a technology which we have been talking about. There's this idea of value creation, which is really through use of tokens and token economy, which is really underpinned by game theory. And again, it's a very interesting and scientific and mathematical concept that we're not really going to get into. However, there's a significant amount of well-established mathematical proofing that's been done on this. So this is not a new thing. And then finally, this idea of a culture, and really it's a culture of decentralization. It's a culture that, instead of having all of my information at one entity and trusting that one central entity, I want to distribute that or have much more ownership directly. And maybe it's distributed across, tens of thousands of nodes. What that gives you is inherently a whole different security scenario as well, because a hacker, instead of hacking just one large entity such as Equifax to get into our credit records, may have to hack into tens of thousands of nodes. So it's a whole different proposition, and possibly one that really is much more beneficial, at least from a security perspective. However, it's also much more complicated than having just one giant centralized outfit and a business they can go to. So as an example, if you have an account on Amazon and you forget your password, chances are you can triage with them and get your password back. That may not be so easy to do, particularly for your private key if you're using a decentralized ledger. So some pros and cons, but all to say, I think you need to understand these. Again, some key characteristics of public DLTs. I think I've largely talked about these, but certainly I'm a big believer that there is a very high degree of security and cryptographic trust. And again, there's plenty of protocols that prove this. You get to machine-based consensus. That's very, very important. That was part of my comments a little bit earlier about computational trust versus just trust. And to me, I'm a believer in, if we're going to use blockchain in these, particularly in these large-scale type solutions, can you get to machine-based consensus? And can you then impute computational trust? We talked a little bit about smart contracts. There's a number of options there. This idea of near-time or near real-time transaction transparency is really important. Not every protocol necessarily provides that. For instance, Bitcoin is not necessarily real-time just because there's some just delays built into the protocol. However, many others do. Global scale, which I think is very important, particularly as you grow your nodes. And then we also talked a little bit about the cryptocurrency idea. Okay, moving on. I'm now going to shift gears a little bit and talk about a couple of use cases that we have been involved with directly, as myself and my team, over the last several months. So I believe sometime in late January, we were contacted by a couple of people on the internet and some colleagues saying, hey, do you know much about this coronavirus? I think people knew about, particularly my background in public health, having worked at the CDC before. And honestly, at that time, we knew just about the same as anybody, because it was just whatever was in the news. And at that time, it certainly hadn't peaked in terms of wall-to-wall coverage. However, we looked into it and realized that there was an opportunity for us to really kind of, I guess, put our money where our mouth is, because we are big believers in really blockchain enabling certain kinds of healthcare solutions. Not everyone is an example, but there are some. So this seemed to be a good one, because even at that time, this is in late January, there was quite a lot of rumblings about distrust of information, about the information being slow, about, like, do we know if somebody's manipulating data for their purposes? So we built this tracker that is public. You can see the URL there on our website, acor.com/coronavirus. And we have been basically evolving it ever since. Every day we update it. We have data that we retrieve from various sources, from authoritative sources such as the CDC, WHO, New York Times, and various other state and local entities, and a number of other global entities. Obviously, we are not the primary data collectors. We are not epidemiologists out there, in the field collecting this data. However, it's very, very important to us to prove that once we get the data from whatever authority, we can prove categorically that we have not manipulated data, we have not changed it, we have not reported it wrongly for whatever reasons, because at the end of the day, we're putting this out there and the public is looking at it. And we don't want to be in a situation where our data is either inadvertently or through just lack of care is wrong, and people are getting worried about data that we cannot, we can't 100% confirm has not been changed by us. So with that being said, really this is what we did. We basically built this idea of data provenance using the Hedera public technology, Hedera hashgraph distributed ledger technology, which is a leading what I would call next generation DLT in this space. It uses a consensus algorithm called hashgraph, and it is significantly scalable. It's very, very fast and very economical. So to give you some numbers as example, we have seen getting to finality of transactions on the mainnet in about 3 seconds. We've seen ability to do anywhere up to really tens of thousands or certainly into the thousands of transactions per second. And we have seen our costs for those transactions be very, very low, far lower than any other protocol. So all to say, we thought this really fit our profile, and we have worked with Hedera for a long time, so we knew the team and knew their direction. So what I'm showing here on the left-hand side, if you can see it, is basically our coronavirus data set that we have in our technology called HashLoad. What HashLoad does is basically ingest the data, and then we essentially transform it into CSV files. And then we have this idea of verifying, and you can see on the right-hand side, there's some metadata, but this idea of verifying that file. And if I show you here, just to basically zoom into this particular verification, by clicking into this button, I'm able to now see the full details of this. I know it's a little bit difficult to see on a small screen, but what this shows essentially right here is what we call a hash object. And that hash object is basically an encrypted reference to that particular file and its metadata. And then what we do is that we track that particular reference on the Hedera mainnet. I'm gonna, as I click through, you'll see how we're gonna do that verification. Basically from there, from the link that we had, let me go one step back. There's a link here they can click on. That link takes you to this independent, what's called the Network Explorer. And what we have done is basically in our page, we have created essentially what we call a confidence score or a trust confidence score by triangulating the results from 3 public explorers, network explorers. So what these explorers do, we have Dragonglass, Kabuto, and Hedera's own kind of tool. What these do essentially is report on public transactions, right? And then what we're doing is that in real time, and obviously I'm showing you screenshots, but this actually happens within seconds. In real time, we are able to look at the results from any one of these 3 explorers. And if all 3 of them essentially match, then we have the 100% score. If one of them doesn't, then we have 67% score and so on. And then if there's a reason, for instance, one of the explorers was down, yet the data is correct, then we can still be sure that the transaction happened. So what this shows you here is that, I'm just giving an example, by clicking down here on the Dragonglass link, we can also go to their native interface and basically see all of the transaction information that was there in detail. Now, of course, for most users, these steps that I've shown are really not necessary. It's going to happen. We really abstract the blockchain usage is happening in the background, it's happening in real time. However, if somebody wanted to audit this, if somebody wanted to say, prove to us that this is what you've done, that this transaction really existed, that's what we're able to do. We're able to essentially show that provenance fully. And then to kind of take it one step further, we actually take this and we apply this idea of data provenance for every single event that we do, and we timestamp every single event. So as you may be able to see here, this is that file we were looking at earlier, this a CSV file from the 17th. And you can see that there's been a number of not transactions, there's been a number of events. There's an original create event, and then a final get event, which is really me tapping onto the file and looking at the metadata. And then what you'll see here is that even a specific event, such as me just tapping on that file, is tracked discretely, and I'm able to discretely verify that transaction on the public DLT. So this is really to prove that every single thing that we do with the data, we can computationally prove those transactions. We can computationally prove what we have done, and there's an encrypted reference on the public mainnet that anybody can go and look at and interrogate for themselves. So the real idea here is this idea of kind of basically compliance, real-time transparency, and really using data provenance in a way that's actionable, where you don't have to. What typically happens in these kind of scenarios is that you have to go out to an auditor, and then they have to spend months looking around for data, and then many times it's very intrusive. It requires a lot of effort to get this information. We're trying to make it completely proactive and completely real time and digestible by really any user. And with that, again, we believe what we're doing is quite usable. However, not necessarily usable enough in context of a real user or if you like, a business user. So for a business user, what we have done is that we have built reporting on all of these transactions. Again, all of this is real time. So, here as example, I have selected the date, May 20th, right? There were 25 transactions for that day. And if I show you here, this is just the bottom part of that screen. I'm able to basically see the transactions that happened on that day. Obviously, it's been filtered. You can see it only happened in the US. Those transactions I've selected. And then you'll also see that I have the ability to download directly from our widget into a PDF or an Excel doc or a CSV document and so on. And many times what we do is that we take this data and we actually do machine learning on it, basically post reporting. So then we can look at additional insights that are not necessarily doable just through our reporting tool. So that's really kind of a full life cycle of ingesting public health data, attaching essentially a distributed ledger, timestamping and data provenance functionality to it, and then reporting on it. So I'm going to move on to our next use case. This next use case is actually much more specific to really treating the current COVID-19 I guess infections, diagnostics for it, and also ultimately triage. We are working with our partners and a company called Safe Health Systems and the Mayo Clinic. Safe, that's the URL, safehealth.me. You can go and see more information about it. And essentially, Safe has a consumer-oriented mobile app, both on iOS and on Android, as well as a very sophisticated backend technology. And as mentioned, we have been working together on this for a number of months to really take this technology and adapt it specifically for the current COVID-19 situation, conditions, and also going forward for triage. So just a little background about the Safe app. These are the kind of functions that are happening right now, such as diagnostics, as obviously mentioned, access to your health records, and the ability to be able to import health records or synchronize your health records from your your backend electronic health record system. Provider services and the ability to look up providers and possibly connect with them for a virtual conference or a virtual consultation. Clearly private and secure, obviously that's very, very key for any kind of healthcare application, and certainly compliant to many relevant standards for security, data privacy, healthcare data and such. So the vision really for DLT, for the work we're doing with SAFE, is really to use it as comprehensively as possible. We have done some of those things. I'm going to show you those implemented, including a demo, and there are some things that we're doing in a little bit. But essentially, this is the idea that really we can use DLT technologies to both enforce the laws and the policies that need to be enforced, but also really provide actionable transparency and actionable data provenance, right? That can be interrogated in real time or near real time. Okay, so I'm going to show you just a few screenshots of the app here. This particular app that I'm showing you is called Health Check, and will be available on the Apple Store very soon. We are in final phases of testing. We have built a white label version of this for a client already that has been live for a few weeks, and they have been using it. But this particular version that I'm showing you is the consumer version. The one that we finished and is in production now was specifically an employer version to be used with their employees. So all to say, you basically log in, and then there's essentially a barcode and your photo. The barcode is the way that we track that particular user without exchanging any kind of PII as we go through our different systems or exchange that data with third parties, including labs. And then once you click on the symptom checker here, you're basically taken through essentially what we call a protocol, or if you like, logic that is really provided by public health entities. And in this case, this logic that we're following rather is basically what the CDC has provided. This is, I believe, the April 29th guidance, if I remember correctly. Essentially, you go in there, you select the initial symptoms that have been worsening. If you select fever in this case, you have to provide the temperature and the number of days. Oops, I did not need to do that. The number of days that you've been suffering from this, and then there's a secondary set of essentially symptoms that you have to respond to, and then ultimately a result is given. In this case, this or what we call an endpoint, a medical endpoint. In this case, the response through the app is stay at home because you're symptomatic, or you contact your manager and
Jim?
say, yes.
Oh, we can't hear you anymore.
Oh, okay, sorry about that. Can you hear me now?
Okay, I think I can hear you now.
Oh,
yes.
Yes, can you hear me? Can you?
Yes, I can. Yes.
Okay, good.
Let me go ahead.
Sorry about that. Yes. the perils of doing real-time work from home.
Yeah.
But anyways, yeah, hopefully we haven't lost you too much. But anyways, so just moving on a little bit. So all to say, this slide was just talking about what the application is doing, at least some of the work. This really is much more specific to how we're interacting with DLT. In this case, again, we're using Hedera. And again, we're using the public mainnet for really kind of transaction finality. Obviously, we're not storing any kind of real patient data or any kind of medical outcomes on Hedera. What we are doing is basically storing a reference for critical decisions, a hash reference for critical decisions on Hedera. So as an example, where the application gives a decision or gives a recommendation that you're symptomatic, we're recording that. So then if later on there was some confusion or conflict about whether or not the app had said that and what was the flow and the logic that led to that, we can prove it. Again, this basically is another decision point where we're saying basically to use this at-home test kit, this lancet for a finger stick to basically get a drop of blood. That drop of blood would go into this cassette, what's called the cassette, and then we process that result basically in real time. We take a photo of the cassette from our app, and then within a few seconds, but roughly 20 seconds or so, you get a result back from the app. But all to say, every one of these transactions I'm showing you, and obviously I've just cherry picked a few from the app, not all of them by any means. All of these are being recorded on the blockchain. So the encrypted reference to the data is being recorded as a transaction. Okay. For those of you guys who are maybe a little bit more interested in technology and the architecture behind this, this is just a picture to show you the flow of what I just described in terms of what we're actually doing and how we're interacting from the app with our technology and with Hedera. So obviously this is a rich topic and we could spend a lot of time on it. If you're interested in the technology itself and the architecture behind it and how we've set up the infrastructure and things like this, I'm happy to answer that in the Q&A section in a little bit. Okay, so we do another thing that's I think quite interesting and as far as I know quite unique, and that is that we create what we call a national health ID, a unique one using Hedera in real time, using specifically the Hedera consensus service. Essentially, as most of you may be familiar, in healthcare, there is no, at least in the US, there is no universal health ID. There is no one ID that basically ties me as Jim Nasr from one healthcare provider to another, from one system to another. So this idea of essentially the same person being counted multiple times in different systems is a very real scenario and leads to all kinds of inefficiencies. And part of the reason, certainly not the entire reason, but part of the reason why we have large administrative costs and inefficiencies. All to say, we thought that particularly with this current situation with COVID-19 and the emergency use authorization ability, that this may be an opportunity for us to essentially lead and propose a idea of creating a national health ID using a blockchain, a public blockchain. And again, we think public blockchain because we think it's very, very important for two reasons. One, for any independent party, including consumers, consumer advocacy groups, healthcare providers, government agencies, to be able to look at this themselves directly and see the algorithm and see that the unique record is created and there's a reference to that unique record, obviously without divulging any patient information. Second thing, this idea that we could provide this algorithm to multiple parties outside of just us. In fact, in reality, this may well need to be done at a much higher level, maybe by the government itself, maybe by some large healthcare consortia, things like this, as opposed to one entity doing it. Anyways, it's a little bit forward thinking. This is a highly political topic, of course, has been for many decades here in the US, and hence the lack of any kind of progress. Unfortunately, this leads into the much larger problem with healthcare of siloed data and entities that really, they're not, I guess, incented or they're, I guess they're really not incented to cooperate and work together. Anyways, I've hidden some of the confidential elements of our algorithm here for obvious reasons, but you can kind of see how we're using the Hedera public DLT and we're generating an ID. And I'm going to show you that in a demo momentarily. And here's the demo. So I'm going to be quiet for a second here and let the demo run. What this shows you is essentially a walkthrough from our admin console of creating a user and then us basically showing that national health ID being created. So here we are, we're creating a user, we're giving the user a specific role. The email address is mandatory. And then again, there are some mandatory fields here. that we have to fill in. Otherwise, we cannot create the user ID. So now that the information has been filled, basically when we click submit, this is really when we start in real time calling Hedera, the Hedera consensus service. And within a few seconds, usually about less than 10 seconds, we generate that national health ID. And you see that national health ID that did not exist. That was basically created in real time. And what we're going to show you here is essentially using a third-party tool called Kibutu. We're going to show you that computational trust or the data provenance. And you'll see here, you see that number there, that's in the memo field or the message field. You'll see that is the same number that we have under the fingerprint. So that's basically it, just a little demo to show this idea of in real time calling a DLT, creating a national health ID, and also then proving it. Okay, so I've kind of wrapped up with my use cases. I just want to, before wrapping up completely, I just wanted to talk about some other things I think are really important. Blockchain is really not a silver bullet of any kind, unless, I'm a big believer that data before blockchain, unless you really understand your data and can really get the data to be interoperable and available and machine readable and things like this, you're really not going to be able to leverage blockchain all that well. Blockchain is infrastructure. So questions you need to ask is, where's the data? Can I get to the data? Where's my data specifically, as opposed to like my patient data? Again, can I trust the data? And that trusting the data is, again, a lot of it is to do with who you're interacting with and what kind of compliance service levels they have achieved and things like this. And then ultimately, what can you do? What can I do with the data? And then finally, this idea of who's accessing the data. And this last one is an interesting point because, again, this is where blockchain can play a role, because right now in healthcare, in almost every case, we really have no idea who's accessing our data. We go to a healthcare provider, a clinic, on a paper form, we provide consent. That consent essentially is unilateral, is basically timeless. And you have no idea who's accessed that information at any point in time. However, with blockchain and some of the innovations we're looking at, I think we're at the place where we can have much more discrete level of consent on who's accessing our data and when, and how much of a time limit or transactional limit they have for doing so, which to me is very exciting. And then also this ties into some new laws are coming into place, particularly what's called the Cures Act, which becomes law in January of 2021, which is all to do with essentially removing information blocking for patients to get to their healthcare data. Okay, so whenever we talk about data, I think it is very important to reiterate that the data is siloed. That's not going to change anytime soon. It may be decades, it may never happen. But certainly for the foreseeable future, what's important is to understand that you're going to have many different data sources. So in order to overcome that, I think you, particularly as an application developer, as an entrepreneur, somebody building technology, you must think interoperability. You must think, how do I interoperate across different sources of data and different applications, as opposed to, for instance, creating one giant application with everything in it, which is just not realistic. These are some of the common standards that we come across and we use. FHIR, which is fast healthcare interoperability resources for essentially interacting with backend electronic health record systems, CDISC, essentially for clinical trial data, Swagger for API documentation, and similarly for OpenAPI. So just a little, I guess, warning. Be careful. Again, blockchain certainly is not a panacea. It's important to understand it is tamper-proof. So you put garbage in, hence my comment about data before blockchain. Now you have tamper-proof garbage forever, and that's a real problem. Similarly, when you put bad code in a smart contracts, it's difficult to upgrade, it's difficult to migrate. So blockchain is native digital. However, most of the things that we want to associate to blockchain, such as a patient or patient record, are real world analog and real world things outside of a blockchain. So it's really important to understand how do you go and map real world to digital, because it's not a trivial thing to do. And again, including things like identifying things and people and software, none of that is particularly trivial to do, particularly identifying people. And hence the comment I made a little bit earlier about our experiments with the National Health ID and using blockchain to try and at least provoke some thoughts around the area. Governance is always complicated in blockchain. It's complicated if you have a private blockchain in so much that as the private network grows, do you keep trusting the same entities, or how does that scale? It's complicated when you're talking public because you know, there isn't necessarily one entity in charge, but then you still do need to scale the network, you need to upgrade software and so on. So it's a difficult concept, and there are definitely some interesting ideas around what makes sense from a governance perspective. It's a rich topic. I talked a lot earlier about consensus. It's very, very important to understand the consensus algorithms because there are definitely pros and cons and trade-offs. So smart contracts, honestly, from an implementer's perspective, there are a lot of issues with smart contracts right now. All the way, anything from developer tools and migration and things like this to just immaturity right now. And generally speaking, I would recommend that you, if you can, you use blockchains for what they're really good at, which is to get the finality of simple transactions, but you do more complex logic using APIs, and you do it off the chain. That's the way we do about it generally. And then dealing with legacy data, which is essentially old data, going back to my point earlier that essentially blockchain is native digital. So just in closing, some points I think we've already spoken about. I think there's a real need for innovation in healthcare. I think it's quite unacceptable that we spend the amount of money that we do here in the US and really many other countries, and it's so inefficient. Certainly in the US, is widely regarded to be the least efficient healthcare system in the world. And again, we're seeing the results, unfortunately, and in people's lives and panic and just a lot of stress for many of us, most of us. Going back to blockchain specifically, I think certainly you got to think data before blockchain. If you haven't figured out your data strategy and don't really understand data interoperability, blockchain isn't going to solve anything. If anything, it's going to create more silos and really more complex silos, and you'll be stuck. Interoperability is really key, both from software and healthcare and data perspective and healthcare system perspective. I think I talked a lot about computational proof and data provenance. I think you can have actionable, or rather accountable actions with computational proof. Again, it's not a silver bullet. You can't use it in every situation, but I think there's definitely a number of use cases. I think the low-hanging fruits are the ones that I kind of think about here: data provenance, data reporting, and timestamping, and fair timestamping of transactions. Because again, if the transactions are manipulated and that timestamping is not fair, you still have essentially you still have ways in which information and trust can be manipulated. Finally, last on this kind of in closing, a practical advice is where you can, as an application developer, abstract blockchain. Your user shouldn't need to know anything about it. It should just happen. And certainly in our case, what we do is we manage native tokens for most of our clients, because that's a scary topic. People are uncomfortable right now dealing with wallets and cryptocurrencies, and many of them get worried about scams and is this Bitcoin and things like this. But also there's some real practical difficulties in doing so. So what we find is that when we build software, we work with our partners, the Hederas of the world, and we abstract those pieces. And then we can prove to our clients or our users that they're getting the benefits of a real-time DLT without having all of the difficulties to manage that. That's really it. Just quick reference if you're interested, just about us. This is about Acore. Really, we're all about building usable technology, real time and blockchain enabled where it makes sense. Myself and my partner Ben are the principals, but the team has been together for a number of years working on different projects. I mentioned briefly our HashLog technology, which is the technology that we use for visualization, and there's many examples and number of clients we work with. And then this HashLog technology, which essentially is for ingestion of data and then timestamping it on a DLT. That's all I have for you. I appreciate your time. I hope I didn't bore you too much. I felt like it was quite a monologue, but I'll be happy to take any questions.
Okay, thank you so much, Jim. Thank you so much for your time. I'll probably just give a minute to see if anybody has got questions from YouTube or on here, because I haven't received any thus far. But is it okay if by any chance anybody has got questions after, I could direct them to you and then you could give feedback? Is that okay?
Yeah, for sure. My email is right there. I'm available on Twitter,
Okay.
LinkedIn. I'm relatively accessible. I'm happy to help out, at all.
All right. Thank you so much, Jim. I personally, I've learned a lot and penned down a couple of things. And I think your product is really, really, really good and very useful. On that note, thank you so much for your time. And I really appreciate. If you'd like to say anything else, May, do you have
Yeah,
anything?
no, just I appreciate the opportunity. I think this is a very interesting topic. I don't think we're anywhere near really kind of exploring it fully. This idea of how do you use blockchain with healthcare. I know there's a number of other use cases. There's a number of people, including us, have looked into supply chain type of use cases, track and trace, things like this. And there's a few other really interesting ones. So I think we're in a good place in that context. It's unfortunate with COVID-19. However, I think we're in a good place to innovate because of COVID-19, right? Because we are all aware of some of the problems that I think we mentioned at the beginning.
Okay. All right, then. Thank you so much for your time. Okay, I think there's hold on a minute. Okay. There's a message from someone. It says, I believe the health ID concept is great, but from an effectiveness standpoint, how do you think it will be feasible to be implemented at scale, let's say country-wise? There are so many competing technologies trying to resolve the same issue that it makes it hard to achieve.
Yes, yeah, it's a really good question. Thank you, Jaime, for that. So, I think that there are two ways to answer this. I think one is really from a technology perspective, which I think is relatively straightforward, and then two is from a business perspective, which is anything but straightforward. So let me take the first one, the easy one, which is technology. So
yes.
we built this, Jaime, we built this technology to scale to a minimum 1 billion people. We built it and we did a lot of performance testing to generate the IDs in real time using this blockchain approach, basically at less than one ID generated per second. So if you had a massive upload, you could still really scale. We use a very sophisticated asynchronous queuing technology for doing so and running many threads. So we've already tested all of that and we have had great results. The algorithm is based on some logic. I didn't share the full algorithm with you guys, but it's based on some logic that's derived from some key things that we know from the user, or we can reliably substitute in other ways, right? Which still generates this unique number. And at the end of the day, what's important is that number to be unique and to be interoperable. And that's where the interoperability part is where we get into difficulties, right? So I give an example. In the current application that we're working on with SAFE, we have a number of partners. They're health providers or such as the Mayo Clinic. There are laboratories such as Quest or LabCorp, molecular labs. What we're able to do is we have worked with them and said, we are going to pass you this national health ID, this number, and just that number for you to identify a patient, and you're going to pass the result back to us for us to essentially update our app and do the electronic handshake. So in that case, that actually worked out pretty well because we're partners and they have bought into this concept. However, as we all know in the US, there's certainly thousands of third parties involved, hospitals and clinics and EHRs, big and small. And to get everybody on board with this is from a business perspective, is challenging. I think ultimately what we like to do is essentially showcase this idea and this concept to a government entity like the FDA, and see if they would like to push it, endorse it, maybe provide some kind of public hearing for it, things like this. Because to us, you have to have a solution, and right now doing identity resolution across dozens of different healthcare systems is very difficult and very costly. Your next question, what is the licensing model? There is no fee, it's free. Yeah, it's completely free. In order for us, we felt all along, in order for this to take off, it needs to be free, it needs to be ubiquitous. We need to provide an API that's available and a toolkit rather, that's available for any third party to use. And we have partnered with Hedera. They have bought into this. They have actually been very generous in providing essentially a number of like a bucket of transactions at no cost to us to enable to do this and for us to really prove this concept. So yeah, we certainly don't want to have a fee for this.
Okay. All right, Jamie, hope you're good with the questions. Okay, if nobody, oh, hold on, there's one more question. Oh, okay, it's just an appreciation. Okay.
Very good.
Once again, thank you so much, Jim, for your time. Hopefully we get to have another webinar or an in-person meeting. And like I said earlier, thank you so much. And
thank you.
Do enjoy the rest of your day.
Yes, thank you, Esther. Thank you, everybody. I appreciate your time.
Yeah.
And
thank you so much to everyone else for joining. Yeah.
Take care. Bye-bye.
Bye.